is something we've looked at before. What does inequality mean? Greater than, yeah. Greater than or equal to, less than or equal to, stuff like that. So essentially these symbols right here. So I want to let you know that these are going to go very similarly to what we've done in the past several days, the past week or so. There's going to be one little change. This is it. One extra thing to consider here. We're going to consider whether the line should be solid or dotted. Let's try that again. Solid or dotted. And there will also be shading around the lines. Does that sound familiar at all to any of you?
Little, yeah.
Some solid line, dotted line stuff, and then we'll actually shade part of the graph to indicate where our answers are. So we'll get into that here in just a few minutes. But for now, I want to do another kind of check-in to make sure that we know how to check our answers. And so I thought we'd do number one first. This is quite similar to questions we've done in the past. I'll read it out loud here. It says, determine whether each ordered pair is a solution of x plus y is less than or equal to 6. So you basically have 4 opportunities to practice this. Basically, you got 4 answers. Somebody has worked on this question. Maybe they've done the dotted solid shading graph, or they've done some work and they've said, you know what, I think I know 4 solutions to this inequality. How is it that we check to see if any of those answers really, truly are a solution? What do you do, Sam?
Wait. You plug in x and y.
You do? Yep, you plug in the x and y from the ordered pair, and then...
You add them.
Right, and then you...
See. Well,
finish your sentence. You said, see if it's like correct. What would be another way to say correct?
right.
Right, or... I was going to go with true. Sam, everything you said was awesome. Great job. Yeah, so I'll just succinctly try to restate what Sam said there. She said, plug in the x and the y from the coordinates. Maybe add the numbers, right? And then determine whether the resulting statement is true or false. That should tell you whether that particular ordered pair really is a solution or not. So let's go ahead and get started right now. Let's try to determine, let's just run through all of them. If you can do what Sam just said, you should be able to make a judgment on all these, all right? So ready, set, go. Start writing. Question, Christiana. Okay. All right, so I'll give you guys just a couple minutes to work on these on your own, and then we'll check to see if we know what we're doing. For number one, or for letter A, what I'd want to see is something like this. Just as Sam outlined, I'd want to see you actually plugging in the x and the y. So you'd say 0 plus 4 is less than or equal to 6. And as she said, let's add them. 4 is less than or equal to 6. Is that true or false?
True.
It is true. So you'd say yes or no?
Yes.
Yes, it is a solution. So you see the work that's leading to your answer? It's not very hard, I get that. I mean, everybody can do 0 plus 4, and everybody knows that 4 is less than or equal to 6. I get that. But I want to see the evidence that you've actually figured it out and have evidence to support it. All right, so then part B, you would say negative 3 plus 1 is less than or equal to 6. And so that would lead us to negative 2 is less than or equal to 6. Is that true or false?
True.
That is true. So once again, yes, that is a solution. And then, with this part C, we'd say 9 plus negative 2 is less than or equal to 6. 9 plus negative 2 is 7. 7 is less than or equal to 6. Is that true or false?
False.
That's false. And so I'm going to put a little slash through that. False. Therefore, the answer is not yes, it's no. Make sense? All right. And then finally, negative 1, 7. We would say negative 1 plus 7 is less than or equal to 6, which leads us to 6 is less than or equal to 6. Is that true or false?
True.
That is true, because 6 is less than or equal to. It happens to be equal to 6, and so you'd say true, and the answer is yes. So I want to see that chaining together of logical, like supportable work and then a logical conclusion. Okay, Sam, your question.
So since it's like 6 is less than or equal to 6, then it's yes. But if it was just like 6 is less than 6, then it would be no.
Correct. Do you guys understand the subtlety on that? Yeah, good question. Anybody else? Okay, fantastic. Let's move on to some graphing here. Number 2, I want to help you choose the best way. So it says graph the inequality 3x minus y is less than or equal to 6. Do you guys see how this is a lot like this? 3x minus y equals 6. Isn't that just like a lot of the other linear equations that we've graphed? Of course, the difference is instead of equals, it's less than or equal to. But that is not going to affect how we graph the line itself. That'll simply affect the dotted solid shading thing that I mentioned earlier. And so let's go ahead and graph this line as if the less than or equal to is not even there right now. Let me ask you a question. What do you think would be the easiest method? Slope-intercept, intercepts, point slope. What do you think? You said, she says point slope, Christiana says slope-intercept, and Danny says just intercept. So we basically got all three opinions represented right there. In this case, I agree with, well, all of them will work. I agree with you on that. But as far as best or easiest method, I would agree with Danny on this one. I feel like intercepts would be easiest because, let me explain my reasoning. Right now, it's not solved for y, is it? If this equation was solved for y, it would already be in slope-intercept form. And so I would agree in that case that, yeah, slope-intercept is easiest. It's also not in point slope either. And so, to me, that's not easiest either. It is perfectly set up right now for intercepts, right? So let's just review really quick. To find the x-intercept, you plug a 0 in for y. To find the y-intercept, you plug a 0 in for x. And so I'm going to do that. So it's going to look something like this. X-intercept. I'm going to plug a...
I have a question.
Oh, you have a question. Go ahead.
If you do like the slope intercept form,
Yep.
don't all you have to do is just move the line and then move that 6 over and then it's in slope intercept form?
Yeah. Yeah. So remember what I said earlier. I hope that you get this. What I said earlier is, what do you think is the easiest method? And the thought there is, I'm asking you for your opinion. And it's possible opinions might differ. I'm telling you I think it's easiest. I think it's easiest. You might disagree. And Christiana, let me say this. Unless I have prescribed, please use the such and such a method, it's wide open. You can use whatever method you want. Okay? But I would just caution you that there will be times when I will say, please use intercepts to graph this. Or please use slope intercept to graph that. So please don't say, I'm only going to learn this way. I'm going to ignore all the other ones. I want to make sure that you can do it all of the ways, because truly, in some cases, one way is easier than the others. Some cases, it's maybe a matter of opinion, right? Okay, so I plug a 0 in for y, and I divide by 3. This will give me an x-intercept of 2. My y-intercept, I plug a 0 in for x. I hope that you are working with me, or maybe you've worked a little bit ahead. That's fine. So it'd be 3 times 0 minus y is less than or equal to 6. So that would be negative y is less than or equal to 6. Dividing through by negative 1. Technically, I'd get y is greater than or equal to 6. I'm not going to get too hung up on the inequality at this point. I'm simply going to say y equals negative 6. That's going to give me my intercept, and I'm going to graph those two intercepts, okay? So my two intercepts are, x-intercept is 2, so that is right about here. My y-intercept is negative 6, so 2, 4, 6, right there. I place those 2 points right there. Now to finish this off, normally we just connected them and put arrows, right? Yeah? I have to make a decision on dotted or solid right now. Dotted or solid. You say dotted. Anybody say the other way?
Solid.
You say solid. Okay. I just wondered if anybody had the other opinion, right? Because there's only 2 ways you could go there.
Solid.
So in this case, it is going to be solid. And here's why. You got to know why, right? The reasoning is, we look at the inequality. What part of the inequality tells us that it will be solid?
Less than or equal.
The or equal to, right? The fact
That's
that...
like the circle on the line graph.
Exactly. It's either open or filled in, right? So the or equal to would be like a filled in solid object. And so because of the or equal to right here, we have to do a solid line. If the or equal to is not there, you got to do a dotted line because it doesn't actually include the line, right? So I will do my best to connect these dots. That's not a very good line. Let's try that again. That's a little bit better. There's my solid line. And then the other thing we got to decide is shading. I basically have to shade, I'm actually going to extend this line a little bit. I'm going to extend it up here. That wasn't very good. Straight line. There we go. I've basically created two regions of this graph, have I not? Mm-hmm. I'm going to say this is up here, this is region A, this is region B. We're either going to have to shade region A or region B. Now you got to be very careful with this because people want to use that and be like, oh, so let's shade over here or let's shade over there. That only works when you are in slope-intercept form. And to get to slope-intercept form, you actually had to divide by a negative, which flips the inequality around. And so there's definitely potential for confusion. The easiest, surest way to determine this is to do a test value. Okay, so here's what I'm going to do. I am going to do a test value back in my original equation, and I'm always going to use the easiest possible test value. I think region A contains the easiest test value, which would be which point? 0, 0. Do you see how 0, 0 is in region A? So I'm going to test it out. Check this out. 0, 0 is right here. So I'm going to plug 0, 0 into my inequality. So it's going to be, sorry?
Isn't that in the middle?
In middle of what?
The graph.
It is, but isn't the line over on the kind of lower right? Yeah. So you see the two regions, right? Region A and region B. I'm going to test out region A to see if it's true. So let's try it out. So 3 times 0 minus 0 is less than or equal to 6. So 0 minus 0, essentially, right? Is 0 less than or equal to 6? In other words, is that true?
Yes.
It is true. So in other words, my test value worked. And so I need to shade where I had my test value. So I will be shading over here. And to be honest with you, Hunter, this would go contrary to what you were thinking, didn't it?
No.
No? Okay. Fair enough. So the shading would happen over there. You just use your pencil or whatever to shade in that region.
Yeah, that's the side I was thinking of.
And essentially, what that really means then is if you pick any point in that shaded region, and there's lots of them, right? If you pick any point in that shaded region, it would make our inequality true. Okay? Question, Sam?
Do we have to shade?
Yes.
But like,
Because
why?
is there any one number, is there any one point that works here? So my question is, so you got this inequality here, right? My question to you is there just one single point that makes that true?
No.
No. There are lots of them. They're all over here in region A. And so by shading, we are representing that all of the points in region A make the inequality true.
Okay.
And by contrast, all of the points in region B wouldn't work. They would make the inequality false. We could test that out too if you wanted to. Check this out. Why don't I just pick one of those points out? I don't know. Let's see here. What would be a point over there? How about the point, do you see how 2, negative 2, which would be right there, would be very close, but not quite in the shaded region?
Okay.
So 2, negative 2. I think it's going to be really close. Oh, wait, hang on.
So 6 minus 2. That works.
Let's see here. No, it does not work.
It's 6 plus 2.
3 times 2 minus negative 2.
Oh, plus.
So it's really 6 plus 2. And that's actually 8, which is not less than or equal to 6. So it didn't work. So the reasoning for the shading, Sam, is that if you're going to graphically represent all of the solutions, you got to say it's all of them in region A. The way that you represent that is to shade it. Or if you wanted to, if you're just like that against shading, you could label your regions A and B and say region A is the answer.
Okay.
And in that case, you wouldn't have to shade at all, right?
Okay.
You just say, hey, it's region A or it's region B. I'm happy with that too. Okay. Any other questions? So I'm going to give you a chance to kind of run with this a little bit with the following examples. We'll just see how you do with graphing and shading and dotted solids. So let's take a look at number 3. Like I said, I think I would use intercept method, but I'm open. Did anybody use slope-intercept? Okay, so let's hear that. So Colby, you decided to do slope-intercept. You said, what did you do to get it there? Because right now it's not in slope-intercept.
I subtracted the 6x.
Okay, I like that. So when you did that, you probably got 5y is less than, did you write it as 10 minus 6x or negative 6x plus 10?
Negative 6x plus 10.
Okay, so that makes sense if you're going for that exact slope-intercept form. I can live with that for sure. And what'd you do to finish it off?
Then divide by 5.
Yep. The numbers work out pretty nicely here, so that's why I said slope-intercept could be a good way to do this. I think could go either way. So I got a question for you though, Colby. We just divided by 5, right? So because I just divided by 5, do I need to take that inequality symbol, the one that's currently less than, do I need to flip it around?
No, it's not negative.
Only if I divide by a negative or multiply by a negative, right? Okay, so y is less than negative 6/5 x. And that works out nicely on the end, right? Plus 2? Okay. So then to graph something like this, when I am in slope-intercept form, let me ask you a question. Do I graph the slope first? Do I graph the y-intercept first, or something else entirely?
The y-intercept.
Always graph the y-intercept first. Yeah, so it's 2. So y-intercept of 2 right there. And then we're going to count off our slope, which is negative 6/5. So the way I would term this is I would go down 6, right 5. So I'm going to start there at my y-intercept. I'm going to go down 1, 2, 3, 4, 5, 6. Right 1, 2, 3, 4. I think that's 5 right there. Okay, so that's my slope triangle. Final questions here as we finish this up. Dotted or solid on the line? Dotted. Why? Because they're
Not equal.
yeah, the or equal to is not there. And so we do have to use a dotted line to connect these points. So I will attempt to do that in a good pattern. Not perfect. Something like that. So there's your dotted line right there. Question, Jake.
So I did, for the x value, I did just 5 times 0.
So you did the intercept method.
Yeah.
Yeah.
I got 10 over 6.
Right, so 10 over 6 would be 5/3, right? So that would be 1.6 repeating. So that's fine. So your y-intercept should have been, well, so Jake, remember, I'm not going to go out the ruler and say, oh my goodness, you were off by 0.5 millimeter, sorry, right?
Yeah, okay.
And so if you're going to be trying to graph a y-intercept of an x-intercept of 5/3, that means your x-intercept, so 5/3 is roughly 1.6 repeating, right? It's exactly 1.6 repeating. And so your x-intercept really needs to be between 1 and 2, like right about halfway between 1 and 2.
Okay.
And if you've got that, I'm happy. If you're anywhere other than between 1 and 2, we have a problem. Does that make sense?
Mm-hmm.
Okay. All right, so then finally, shading.
Left side.
Again, I advocate for a test point here. We basically have region A over here on the left, region B on the upper right. And we have a good test value right there. Do you see how 0, 0 is in region A? I would consider that. So let's try it out. This should work in either our slope-intercept or our original. I'll just use the original here. Test value, 6 times 0 plus 5 times 0 is less than 10. 0 is less than 10. Is that true?
Yes.
True, yes. And so that means the region that contains my test value is my answer region, so I need to shade there. That would be region A in this case. So yeah, like you said, Rocky, left side, lower left side is the, oh, you got to remember the Titans quote in there. Nice job. Okay, so there's my shading. The shading goes right up to the line, but does not include the line because the line is dotted. Right? If the line were solid, it would include the line. Because the line is dotted, it does not. Sam, question.
So how do you know if you have a dotted line or? Oh wait, never mind. I know.
Are you sure? Okay. Any other questions? Yes, ma'am. Amelia.
Have you ever had to, like, on a test, go see, like, you're given a dotted line and you have to find out what the equation is for that?
Well, that wouldn't be any different than if it was a solid line. Are you referring to the inequality?
Yeah, like we have.
Well, I'd have to give you shading as well, wouldn't I?
Yeah.
Yeah, sure. I mean, I'm not going to say yes, that's on the test, or no way, that's not on the test. I'm not going to say that, but you should be able to take a graph of this and determine, like especially if I gave you a dotted line, you should be able to say, well, it's definitely not or equal to. And if I gave you the shading, you could go backwards and figure out whether it was less than or greater than. Sure.
Okay.
Yeah. Okay, let's take a look at number 4. So here we go. As mentioned, slope-intercept form is easiest because this is already in slope-intercept form. Y is greater than -1/2 x. So let's remember our y-intercept here is 0 because there is no plus b. The y-intercept is 0. So we're going to plot that first like we did before. So I'm going to just put a 0 right there. Y and x-axis, really it's the origin, isn't it? And then of course the slope is -1/2. So that means from our y-intercept we go down 1, right 2. So I'm going to try to do that here. So down 1, right 2. I'll put a couple of points in here. Down 1, right 2. Down 1, right 2. You can kind of see my stair steps and my points, right? I'm going to connect those, but am I going to connect those points with a dotted line or a solid line?
Dotted.
Dotted, right? Because there's no or equal to. So here is my attempt at that. I guess technically what I'm doing is more of a dashed line, isn't it? There we go. You guys have something similar? Okay. Finally, shading. Shading. So, as mentioned before, 0, 0 is actually right on the line. Ben used 1, 1. Christiana, what did you use for a test value?
I used 1.
You used 1, 1? Okay.
It's the easiest one.
I agree, it is the easiest one. No messing around with positives or negatives and low numbers, sure. So we're going to test out 1, 1. So it's going to be 1 is greater than -1/2 times 1. 1 is greater than -1/2. Is that a true statement?
Yes.
Yes, it is. And so the region containing 1, 1 is our answer region. So I will shade there. So that would be the upper right. We've been really lucky today. We've picked some good test values. What happens if your test value results in a false statement?
You shade the other side.
Just do the other region, right? Shade the other region. That's exactly right. Okay. Got 2 more, but they're a little bit different as far as what the lines look like. So just kind of a moment of just pause right here. Are you doing okay? Doing okay with slope-intercept and intercepts and all that stuff?
Do you not want to use point slope in this stuff?
Well, if it's in point slope form, yes. But nothing we've looked at in this section so far has been in point slope. So far, I don't think that would have made any sense yet. So short answer, no. Verse 5 and 6, you can see the equations up there. Did you notice that in 5 and 6, they're a little bit different looking because in all the other ones we've done, hasn't there been a y and an x, 2 variables? But of course, in number 5 and number 6, there's only 1 variable. So, what kind of line is number 5?
Vertical.
Vertical, because if you tried to ski it, you would get x'd out, right? So that means number 6 must be,
Horizontal.
because why would you ski it? It would be boring,
You're skiing cross country.
super boring, unless you're doing cross country. Then you're just looking for a
Why would
workout.
Why would you do that?
And why would you do that? That's my question too. All right, anyways, so see if you guys can handle numbers 5 and 6, knowing that they are vertical and horizontal lines. Ready, go. As we mentioned a second ago, number 5 is a vertical line. It's a vertical line that goes through -2. Well, we got to decide, is this going to be a dotted vertical line or a solid vertical line?
Solid.
It is solid. It's going to be going through -2. Oops, let's try that again. There we go, -2. And so maybe you just literally use a dotted line like this. Oops. You can do dashed like we've been doing, or you could do dotted like this. I'll just do dash down here. Wait a minute. Did some of you say dotted?
No.
Did anybody say solid?
Yeah, we were.
Solid.
I was just hearing what I wanted to hear. I thought I heard one person say dotted, so I was just going to go with it. Why is it solid? Because it is solid.
It's greater than.
And it's the equal to part, right? So let's go make that solid. maybe my ears are hearing things. Oops. Let's go like that. And again, just like the other lines, haven't I essentially divided the graph into two regions? I'll call this region A, I'll call this region B. I got to figure out where to shade. What would be the easiest test value? 0, 0. Yeah, so essentially we plug a 0 in for x and say, is 0 greater than or equal to negative 2?
Yeah.
It is. Yeah, 0 is bigger than or equal to negative 2. So we shade the region B that I marked up here. So it's the right half of the graph. Region B. Okay, and then let's take a look at our other graph as well. So with number 6, as we said before, horizontal line at 4. Ellie, did you decide, is this a dotted or solid horizontal line?
Dotted.
It is dotted, you're right. So at 4, let's see here, 1, 2, 3, 4. Like so, region A is up here, region B is down here. Ellie, did you do a test value to decide which region? What did you use for a test value?
Settle.
Do you agree with Rocky that 0, 0 is the right number to test? Okay, so that's region B, has 0, 0 in it. So it's essentially be 0 is less than 4. Is that true?
Yes.
It is true. So we'll be shading in that region. We have done a good job of using good test values that give us truths. So shading below in region B would be our final answer. Last question to go here, number 7. Together. You guys have done really well today. Let's finish strong. We'll get to our questions as well. This says, Carly is going to purchase some CDs and DVDs. If each CD costs $12 and each DVD costs $20, write and graph an inequality to represent the number of CDs and DVDs she can buy if she wants to spend, keywords there, at most $180. That indicates an inequality, right? At most. You could spend less than that, but not more than that. So we got to write a little inequality here. Let's do this. Let's set up some variables to help us. Can we say that the number of CDs that she buys is represented by the letter X? And the number of DVDs that she buys is represented by the letter Y? Does that work? So number of CDs is X, number of DVDs is Y. So let's see if we can write an inequality. If each CD costs $12 and each DVD costs $20, what could we write for the cost that the amount that she spends total? Rocky, go ahead.
$180.
Let's not worry about the 180 yet. Let's just worry about how much she spends. So forget the 180 for now.
20 times Y, however many.
20Y
12x.
plus 12x. Wouldn't that be the cost? $20 for each DVD, $12 for each CD. You just multiply by the number of each, add them up, and you'd get your total cost. Now, the reason why I stopped Rocky short on the 180 is I think when you write it this way, it's actually a little bit easier to determine the inequality, right? How much at most does she want to spend?
180.
Okay, so I'm going to put 180 over here. And so over here on the left, isn't this how much she actually spends? And she wants to actually spend at most, which is another way of saying
Less than or equal to.
less than or equal to, because she could spend 180, but not more than that, right? So less than or equal to would be your inequality. I feel like if you build it this way, it's a little easier to get that inequality set up correctly. Okay, so we've got a nice inequality here. In just a second, we'll graph it. Yeah.
Would it work if you said less than 181?
No. Mathematically, no. Practically speaking, because you can't buy half a CD, yes. But mathematically speaking, no. Right? Because we were talking about what's known as discrete data. Right? You can't buy 1.7 DVDs. So I get what you're saying. That is logical, but from a mathematics standpoint. Because if you weren't dealing with discrete data, then there are lots of numbers between 180 and 181, right? But yeah, good point. Okay, so please take this inequality that we've just arrived at from Rocky's efforts here, and let's try to graph it. Let's get the dotted solid shading thing correct. You got the graph down below. Please note that DVDs should be the y-axis, right? Because that's how we set it up. And CDs should be the x-axis. Check to see how you did. We'll make sure we get the dotted solid shading correct as well. With intercepts, let's see, I'll just try to squeeze this in over here on the right. To find my x-intercept, I need to plug a 0 in for y. So that's going to be 20 times 0 plus 12x equals 180. If I divide both sides by 12, what is 180 divided by 12?
15.
15? Yeah, 15 I think. Yep, so my x-intercept is 15. To find the y-intercept, I plug a 0 in for x. So it would be 12 times 0 right there. Dividing both sides by 20, I think the y-intercept is 9. So then I go back to the graph. My y-intercept being 9, I'm going to put that roughly here. And my x-intercept is 15, would have to be over right about there. Remember, x is the number of CDs. This is the number of DVDs. Am I going to connect those two dots with a solid line or a dotted line?
Solid.
Solid, yes, agreed. All right, and then shading. I think we do a test value. Again, our favorite test value here would be 0, 0. So that would give us 20 times 0 plus 12 times 0. Please don't pack up yet. I got a couple of good questions that are up there on the board. Okay, and then 0 is less than or equal to 180. Is that true or false?
True.
It is true, so that means our test value worked. Therefore, we would shade the region that contains our test value. So that would be over here. That's true, you can't buy negative numbers of CDs or DVDs. So we'd probably restrict ourselves to the first quadrant. But since 0, 0 is over there, we've got to shade that region right there. So any data point within that shaded region would represent the number of CDs or DVDs that you, in combination, could buy. We good? Awesome. Okay, let me turn to the questions that we have on the board.